Welcome to Simply Pi Maths.
In this video, let's learn how to solve linear equations which contains variables in the denominators like this. Okay, so if you see, we have two sets of linear equations. One is over here and one is over here. And in both the equations, what you can see is the variables, that means the alphabets, are in the denominators. Okay, so in order to tackle such type of equations, or in order to solve such equations, you need to remember that if I ask you, when after writing 2x, if I ask you who is along with 2, so your answer will be simply x, which is very true. If I ask you 4 and along with 4 I am writing a variable y, and if I ask you who is there with 4, so your answer should be y, isn't it? But at the same time, if I write 2 and I write this x below, and if I ask you the same question like who is there with 2, you can't say just x, because if the x is beside, then we can say yeah, along with 2 we have x. But in this scenario, if I ask you who is there with 2, so your answer should be 1 upon x. The reason being x is in the denominator. Okay, so to make it more simpler, let me take one more example. Like let's say 5 upon m. If I ask you who is there with 5 now, it's not m, it's 1 upon m. So who is there with 5? It is 1 upon m. So basically, whenever something is in the denominator, and if I ask you who is standing with this number, so your answer should be 1 upon that variable. Okay, so the same goes something like if I say 2 upon 3, and along with that if I write x plus y, and if I ask the same question, who is there with 2 upon 3, so the answer is x plus y. Simple as that, because along with 2 upon 3 we can see x plus y. But at the same time, if I write 2 upon 3 and over here I write x plus y, and if I ask you the same question, who is there with 2 upon 3, so the answer is not just x plus y, because if x plus y was in the numerator, was above over here, then I could say yeah, along with 2 upon 3 we have x plus y. But in such scenario, when 2 upon 3 is still there but x plus y is there in the denominator, then if anyone asks you who is there with 2 upon 3, so your answer should be 1 upon x plus y, because this x plus y is not in the numerator, it is in the denominator, right? So who is there with 2 upon 3, so the answer is 1 upon x plus y. Okay, hope this concept is clear, because based on this we will be able to handle such equations very easily. So let me just rub this off, and let's focus on these equations. So as a very first step, as we usually do, what we have to do is first we have to write the solution, and we have to start with. So I will write this first equation over here. 2 upon x minus 3 upon y is equals to 15. Even if this equation doesn't look a good equation, we will number it as 1. The reason is because after a couple of steps this will get converted into a very nice equation. Similarly, I will pick up the next equation, 8 upon x and plus 5 upon y equal to 77. I will number it as 2. And now I need to observe that who is there with 2? I could see 1 upon x. Who is there with 8? I could see 1 upon x. Isn't it? So 1 upon x is there with both these numbers in both the equation. Similarly, who is there with 3? It is 1 upon y. And who is there with 5? It is also 1 upon y. So we could see 1 upon x and 1 upon y is something which is there in both the equations. So in order to start such a solution of such equations, what I will write is, let this 1 upon x be termed as something like a, and 1 upon y be termed something like b. This is completely your choice. We can name it as m, n, p, q, anything as such, but something other than x and y, because x and y are already used, right? So I'm terming it as a and b. So what do you understand by this? If I ask you who is there with 2, so the answer was 1 upon x, right? Now I am removing this 1 upon x and I will place a over there. So what this first equation will become like? It will become something like, along with 2, who was there along with 2? It was 1 upon x. But what did I name this 1 upon x as? A. So along with 2, now 1 upon x is replaced by A. Similarly, along with 3, who is there? 1 upon y. But what did I name this 1 upon y as? B. So along with 3, whom should I write? I should write just B is equals to 15. So here what I did is, I just substituted these values over here. Okay. So what I will say that therefore equation 1 and 2 will become this. So this is actually the conversion of my first equation. First equation is becoming something like this. Let me name it as equation number 3. Okay. And the same way in the second equation also I will do the same thing with second equation. What I will do, along with 8, who is standing with 8? 1 upon x. But what name have I given to 1 upon x? As A. So along with 8 we will write A, and along with 5 we will write B, equal to 77, and this will be equation number 4. So these two equations have become like this. Now this is a very simple cute equation, right? So now let's focus on this and let's apply our concept that we had applied earlier as well. So how to solve these equations? So now you have to just forget about these weird equations. Now it has converted into new equations by substituting these values. That is the trick behind this type of critical sums or this type of complex sums. So the simple way is like, whomsoever you see with the numbers, just name it as something like AB and put these values over here and say that equations, these old equations will become something like this, which are the new equations. Now your complete focus should be on these two new equations. Let's think like how to solve these equations, right? So if you remember, we have used the concept of same term, same sign, subtract. So if I see this is 8a and this is 2a, they are different, right? But by doing something over here, can I make it same? Yes. If I put a 4 over here, if I multiply a 4 over here in this equation, 4 2s will become 8, and this is already an 8a, so we will get same term. So let's try to get that. So I will say multiply, what should I multiply? Multiply equation 3 by 4. So let's see what will happen over here. It will become 4 2s are 8a, which I wanted, and here also the 4 will come. 4 3s are 12b, and 15 4s are it's 60. So this is my new equation. So basically I have converted this third equation into a new equation, and the focus or the aim over here was to get the same term. So now let's try to recall what was the concept saying. Same term, same sign. If you see, the signs are also same. Same term, same sign means these are positive, right? Same term, same sign, then subtract them. So I will simply say subtract. Whom should I subtract now? Subtract equation 4 and 5. 4 and 5. So what will I get now? While subtracting, let me write this over here. 8a plus 5b is equals to 77. And the next equation just below that, 8a minus 12b equals to 60. And as I know, to subtract, I need to leave an extra line over here just to change the sign. So this negative will become a positive now. And here there is positive, that will become negative. So let's complete this off. We have to subtract these two, right? 7 minus 0 is 7. And 7 minus 6 is 1. Here 8a, 8a, when they get subtracted, they will get cancelled to each other. So basically I don't have to write anything over here. I just have to write something here now. Plus plus is plus. So when we add them, it will become 17, and along with the alphabet B. So ultimately what do I have? I have 17. I have 17b is equals to 17. But my aim is to find out the value of b. So b is equals to, I will bring the 17 down. So it will become 17 upon 17. Being same numbers, they will get cancelled to each other, right? 17 ones are 17 ones are, so answer is 1. Getting b will not do the work. I need to get the value of a as well. So let me see some equations where a is present. So if you see in these above equations, a is not present anywhere over here. A is present in these three equations, right? So I have to get the value of a by putting the value of b in any of these equations. So I have the value of b as 1. So let me just finally write, therefore b is equals to 1, and I will add a line saying that put, what should I put? b equals to 1 in equation. Let me just identify an equation, a good equation to put this value. You can take any. Let me take this third equation over here, which is 2a minus 3b equals to 15. So first of all, I will just write the equation over here as it is. 2a minus 3b equals to 15. Then I will simply put the value of b over here. So it will become 2a minus 3 times 1 is equals to 15. So it will become 2a minus 3 ones are 3 is equals to 15. Just to wrap up this, minus 3 will come over here. It will become plus 3. So it will become 15 plus 3. So it is nothing else but 18. 2a is equals to 18. And finally a is equals to 18 upon 2. I just brought this 2 over here. 2 ones are 2 nines are. And ultimately I have the value of a as well. A is equals to 9. Okay. So I have the value of b and I have the value of a. So let me just write it together, something like this. Let me just draw a line over here. And what are the values of a and b? A is 9 and b is 1, isn't it? So let me write therefore a is 9 comma b is 1. Simple as that. Now just wrapping up. So remember, we are not at the end of the answer, like we are almost towards the climax, because the thing is, the ultimate aim of all the sum is to find the value of what? The value of x and y, isn't it? These are the main heroes of our picture, right? So now what we have found is the value of a and b. Now what to do? How to get to x and y using these values of a and b? Any clue? Right? So what we will do? We will resubstitute the value of a and b. What was the value of a and b, by the way? A was 1 upon x. Over here in the left hand side you can see a was 1 upon x and b was 1 upon y. So simply what we will do? We will resubstitute these values of a and this value of b over here. So I will say resubstitute value of a and b. That means instead of a, I will again write its own value, which was 1 upon x. So 1 upon x is equals to will become 9. And instead of b, I will write its value, what it was. B was 1 upon y. So I will write 1 upon y equals to 1. So basically these numbers will remain the same. Only what I am doing is, instead of a, I am writing its value. And instead of b, I am writing its value. This b is 1 upon y. I am just writing it over here. B's value over here and a's value over here. And finally, to get towards the end of the answer, end of this solution. So what to do now? There are various ways to understand this. So the simplest way is like, send this x here and send this 9 here. Just swipe them. So 9 will come here and x will go there. Same thing over here. Send this y there and send this 1 here. So y will go there and 1 will come here. Hey, 1 upon 1 means it is 1 itself, right? So finally I can say value of y is 1, because 1 upon 1 means 1. And over here, what is the value of x? X is equals to 1 upon 9. So ultimately we have the value of x and y over here. Now let's see how to tackle this equation. So this is again an equation of the same type, where the variables are in the denominator, alphabets are in the denominator. So in order to start this start the solution of this equation, first of all I will just copy this equation over here and I will number it. Let me just copy it as it is over here. First equation, and let me number it simply as 1. Then let me pick up the next equation just beside that, come over here. So it will become something like 3x plus y minus 1 upon 2 3x minus y is equals to 1 upon 8. I'm numbering it as 2. Now as we did for the last sum, we need to focus on both the equation and we have to identify who is same in both the equation, who looks very much same in both the equation. If you look into this term 1 upon 3x plus y, you can see the same 1 upon 3x plus y over here, isn't it? Similarly 1 upon 3x minus y, if you see here also you can see 1 upon 3x minus y. So let me just name these two terms as something a and b, or m or n, anything you can name. So here I will say substitute, or we can simply say, what to say substitute, I will just say let. let what? 1 upon 3x plus y as, let me name it as a, and 1 upon 3x minus y is equals to b. By doing this, what will happen? The equations will change now, right? So what was the, what was the wording that we used last time? So substituting the value of, we use the same, right? Without substituting, or else we can also say like this, therefore equation 1 and 2 will become, equation 1 and 2 will become, what will it will become now? Instead of this circle, I will write a, isn't it? So it will become a plus, what is this now? This is termed as b, so it will become b is equals to 3 upon 4, correct? So this is the first equation, and let me just put a comma over here, and for the next equation, this one, what I will do, instead of this thing, I will put a over here. So remember, there is something in the denominator, so let it be in the denominator. So this will become a, and it will have a in the 2 in the denominator. So a will be there, and this will become 2 in the denominator. Similarly, the second term also, what will this become now? This circled part will become b, correct? This entire part will become b, and whatever is there in the denominator, it will remain in the denominator, is equals to 1 upon 8. Okay, so that's how the equation 1 and equation 2 has converted into these two equations. But still, these two equations are not clear enough to be numbered as such. So what I will do is, I will try to get rid of this 4 at the first place. So how to get rid of this 4? I will multiply throughout by 4, isn't it? So here I will just bifurcate this into two pieces like this. So here what I will do is multiply throughout by 4. So it will become something like 4a plus 4b is equals to, when I put 4 over here, 4 and 4 will get cancelled, and I will get 3. So I will just add a word over here, we get, so that I don't have to show the working. I can directly write like, this is what I get. And this looks to be more decent than this. So let me number it as the next number. What was the next number? 1, 2 has already been used, and I will name it as number 3. Similarly over here now, what should I multiply now here to get rid of these numbers? So if I just give it a thought, so multiplying throughout by 8 should be sufficient. Why so? So if I multiply throughout by 8 and it will get cancelled over here, and this 2 will cancel 8, 2 1s are 2 4s are, again 2 1s are 2 4s are. So multiplying throughout by 8 should be enough, right? So let me do that. Here I will write multiply throughout by 8, we get, what will I get by multiplying throughout by 8? If I put 8 over here, 2 1s are 2 4s are, so it will become 4a. If I put 8 over here, 2 1s are 2 4s are, I will get 4b. And finally over here, if I put 8 will get cancelled, I will get 1. This is a more decent equation than this. So let me number it as equation number 4. So I have two new equations over here. Let me focus on this now. So if I look at this, can I see something like same term, same sign already? I do see same term, and let me look at the sign. This is positive, this is positive. So as we use the concept same term, same sign, we can subtract them. But over here, if I take another look, right, I could see something, another, from a different angle also I can see something over here. If I look at the next two variables over here, b, 4b, same term, different sign. So same term, same sign should get subtracted. Same term, different sign, if you see, it should get added. So by that said, with these two equations, you can do either subtraction or addition. Both will give you some or the other answer. Okay. So if I compare subtraction and addition, I prefer addition more, because addition is more simpler. We don't have to bother about the signs and all. So since we could see same terms, different sign, so I will prefer using addition over here. So I will say add equation 3 and 4. Again, as I said, same term, same sign concept can also be applied. Same term, same sign, subtract them. Even if you subtract them, you will get the same answer which you will get by adding. Probably while you subtract, your A will get cancelled and you will get a value of B. And while I am adding now, probably B will get cancelled and I will get a value of A. Either ways, you will get one of the variables result out. So let me just add now. 4A plus 4B is equals to 3. And next one, 4A minus 4B is equals to 1, and I am simply adding them. So as I said before, 4B, 4B, same term, different sign, they will get cancelled. Don't cancel it over here, just cancel it in your mind. This will get added to give you 4. 4A plus 4A, it will become 8A. So finally, A is equals to 4 upon 8. Just I brought this 8 over here. 4 1s are 4 2s are, and I hence have the value of A as 1 upon 2. Fine now. Now what I have to do is, using this value of A, I need to find its pair B, right? So now let's focus on the equations which I have for A and B. These are the two equations containing A and B, right? By putting this value of A in any of these equations will give me the value of B. So shall I do that now? So what I will say is, I will just say put the value of A, I will just say put, what should I put? A equals to 1 upon 2 in equation. I have two equations, 3 and 4. Yeah, so I do have two equations, 3 and 4. I can put it in any of the equation. So let me put it in equation number 3. So I will say in equation number 3. So first of all, I am just copying this equation number 3, 4A plus 4B equal to 3. So let me just copy it over here. 4A plus 4B equals to 3. And now I will put the value of A inside it, right? So it will become 4. Beside 4, I will just put 1 upon 2. And 4B is equals to 3. 2 1s are, 2 2s are. So I have finally 2 plus 4B is equals to 3. And I will send this 2 first over here. So it will become, therefore 4B is equals to 3 minus 2. So 3 minus 2 is nothing else but 1, right? Let me just take some place over here beside. So this will become 4B is equals to 1. And finally B is equals to 4 will come down, 1 upon 4. Let me write both the values together, A and B. So A was 1 upon 2 and B is 1 upon 4. A is 1 upon 2 and B is 1 upon 4. As we said before, finding the value of A and B are not enough, because ultimately the objective is to find the values of X and Y used in this sum, isn't it? So now what I will do, I will resubstitute the values of A and B. Okay, resubstitute the values of A and B means what? Instead of A, I will write the value of A. By the way, what was the value of A? If I just go up, value of A was this thing. Similarly, I will put value of B over here. What was the value of B? Value of B is over here, this one. Okay, so I will just add a line saying that resubstitute the value of A and B. We get. Let me do that in the next page. So here I have resubstitute the value of A and B. So A was 1 upon 2 and B was 1 upon 4. Instead of A, I just put the value of A, which was there at the very top. And instead of value of B, I just put the value of B. By doing this, we have something containing X and Y, and finally few more steps to find the value of X and Y. So let's think about this as we did in the last sum. Let's do like this. Let's bring this thing over here. So what this will become? 3x plus y I will bring over here. It is 1, right? So it will become 3x plus y itself. Because it is just 1, it will not matter. Bring this 2 over here. 2 1s will become 2. But this doesn't look good. I will just reverse it and I will write therefore 3x plus y is equals to 2. I will do the same thing beside over here. 4 over here, so 4. And 3x minus y over here, so 3x minus y. This doesn't look good, right? Usually xy term should be always on the left side. I will just swipe it. So I will write 3x minus y and 4. It is just a swiping, right? I am just swiping this over here and that over there. LHS RHS swiping is done. So I have the proper two equations with me. Let me just see what was the last numbers that I used. I used the last number as 4. So ideally this should be 5 and 6. 5 and 6. And we are towards the end of the solution. So looking at these two equations, what do you think? What should we do? Again the same concept. Here I could see same term, if you see same term and having a same sign 3x 3x, same term same sign can be subtracted. We can either subtract, or else if you see same term y y, different sign, same term different sign, add. So you can add them also. Again the same scenario occurred, like you can either add or subtract, both will give you the results. So I always prefer adding over subtraction. So I will say I will just say no need of therefore, I will say add equation 5 and 6. So let's see, when I add both of them, what will happen now? I will write 3x plus y is equals to 2 above. The next equation 3x minus y equal to 4 below, and I will simply start adding them. So what will happen now? This will give me 6. This are same term, different sign, they will get cancelled to each other, and this will give me 3 plus 3 6x. So I have something like 6x is equals to 6. But I am moreover interested in x, so I will just send the 6 below. So 6 came down, 6 got cancelled. So finally I have the value of x as 1. Let me not put it in a box, I will put it at the end. So I have the value of x. Now as obvious, like I will say, put x equal to 1 in any of the equation which contains x and y. So just above I have a couple of equations containing x and y. I can put it in either of them. Let me put it in 5. So I will say in equation 5. I will just copy this equation over here. 3x plus y is equals to 2. And inside this, instead of x, I will just replace it by 1. So it will look something like this, right? And finally we are towards the end. This is 3 plus y is equals to 2. And in order to get y, I will have to send this 3 beside. So plus 3 will come over here as minus 3. And ultimately I have value of y also as minus 1. Done. So let me just wrap up the answer neatly, saying that x is 1 and y is minus 1, and that is my solution. X is 1 and y is minus 1.